Hello friends, these are our today's points. These are the important terms, very important terms which you need throughout the subject thermodynamics. Intensive versus extensive properties. Okay, what is mean by intensive property? Then extensive property. After that, we'll see what is difference between state function and path function. After that, we'll see work and heat, how these are related to each other, and difference between state function and path function also include this example. Okay, then energy conservation. Okay, friends, first we'll see intensive versus extensive property. Friends, this is a definition. What is meant by which property which just depends independent of the mass, okay, or amount of substance present in the system is nothing but intensive properties. For example, temperature. Okay, just a second. Let's see what is meant by extensive property. Okay, properties which depends on size or amount of substance, or you can say mass present in the system. Okay, is nothing but extensive properties. Okay, friends, we'll clear this and we'll simply write down intensive. Okay, depends on, sorry, independent on, okay, of size or mass. Okay, and example, temperature. Okay, suppose this is a beaker. Okay, we have water in it. It so its temperature is somewhat, suppose it's completely insulated. Okay, or you can say it is in atmosphere. Okay, just like a cup of tea or glass. Okay, at its temperature is same as that of atmosphere, for example 25 degrees Celsius. Okay, and if you reduce or take some volume of this tea, okay, and for example 50% of volume, okay, down, okay, or poured into another cup, then then its temperature is does not affected by this. Okay, that means temperature is independent of mass. Okay, this is a intensive property. Then extensive, its properties which depends on mass. Okay, mass or size. For example, volume. Volume is extensive property. Okay, it depends on system size. Then even mass, consider mass. After that, total enthalpy or entropy. Okay, total, not per mole or per kg. Okay, this is one important thing. I have to explain, just a second, clear this. So consider enthalpy. Okay, when you, instead of enthalpy, will, okay, let's take enthalpy. Friends, in when the term property is enthalpy per kg of substance, okay, means its unit is joule per kg. Okay, then this is intensive property. Okay, an intensive property. Okay, now take another example of same enthalpy. When this enthalpy is in general multiplied by mass, for example then it comes into extensive. Okay, its unit is going to be joule. Okay, extensive property, enthalpy per kg. Okay, similar about density and mass. Okay, density is independent of uh, amount of mass. Okay, density of that much 1 kg substance or of 2 kg or 100 kg substance is same, but their mass are vary. Okay, means density is intensive property but the mass is extensive one. Okay, density is intensive and mass is extensive. That's it. Okay, I think you understand what I mean. Okay, when you divide something as any property, okay, by mass or by number of moles, you can take here mole cells. Okay, then this extensive property will become intensive property. Okay, we'll see next. Then path function and state function. Okay, that's friends, read this definition. State function is a property, okay, which describes particular state independent of path taken to reach this state. That much simple is this. And the path function which depends on path, okay, it covered. That much simple is this. In simple way, just will clear this. Okay. For example, change in enthalpy. Okay, this is one point and this is another point. Okay, at this temperatures. Here enthalpy in the sense, just a second, H. Okay, H1, H2. Okay, if I will ask you what is the enthalpy of the system. Okay, change in enthalpy of the system, what you will say? Just you will say H1 minus H2. Okay, delta H. Just it depends on first initial condition and final condition. Okay, independent of anything else, means it depends on this temperature. Okay, in next video we will see what is meant by enthalpy. Okay, it this enthalpy depends on this temperature. Okay, means delta H equal to, you can say, mcp t, just a second, for here t1 minus t2. Okay, that much simple is this. Okay, this is a, just depends on initial and final conditions independent of path followed by system. For example, system takes this path or this path. Okay, delta H will not get affect because it just depends on initial and final temperature. That's it. Okay, this is a state example of state function. Friends, now we will see path function. We will clear this. Take about work. Okay, the system, the pressure, volume. Okay, just a second. Initially, suppose I am at this temperature and I want to reach at this, sorry, at this position, and I want at this state. Okay, state is a perfect word. I am initially at this state, my system is at this state, and I want to reach at this state. How can I For example, I have taken this path. Okay, I have choose this path. Then work is equal to P delta V. Okay, friends, PdV. Just a second. Okay, we'll see how this definition comes. Okay, friends, here V is differential. Okay, means as the system proceeds to reach at this state, the work depends on each point. Okay, it depends on which path you followed. Now suppose I have changed to this path. Okay, then my by this path, let's my work is W1, and by this part my work is W2. Okay, then this W1 may be less than W2. Okay, for same change in state. Okay, means it's depend on path. Okay, that's why this work is path function. Similar the case about the heat. Okay, we'll see. We will clear this. File open. We don't need to save it. Okay. Now, friends, we'll see about work. When force acts through a distance, okay, that's it, friend. Okay. Now, unit of force is nothing but Newton, and dl is nothing but distance or change in distance. Okay, for example, I have moved this rock from here to here. Okay, then the distance between them are dl. Okay, and force which required to move here is nothing but F. Newton and dl is nothing but meter, combinedly joule. Okay, this is a work definition of work, or how work, meaning of work. Now we'll clear this. In thermodynamics, we mainly consider compression and expansion of the gases. Okay, Okay, this is how PdV W is equal to minus PdV. Okay, why this negative sign is? For in case of compression, our volume will get change, means V2 minus V1. Okay, it causes this term negative. Okay, but we are applying force in a direction and work is taking place in the same direction. Okay, to avoid in that case our work should be positive, but here if we not put this negative sign, our work will get negative, and this is wrong. That's why we have written here minus sign. Okay, we have given here minus sign. I think you understood what I mean. Okay, now just a second. dw dw dw. Okay, this is a differential work. Now to find out the complete work, we have to integrate this minus p dv from v1t to v2t. Okay friends, now remaining is depends on how p and v are related. Okay, which path you followed, we'll see in future with the example. Okay, how can we find out work? That's it friend. In case of compression, force acts in a direction of force applied. That's why here negative sign. And the work is positive. If you calculate work, it is positive. Don't need to save it. First, we'll clear this. Okay, friends, we'll see about energy. Time is running now. By second law of motion, okay, Newton's second law of motion tells us fusion mass into acceleration. Okay, then this acceleration can be written as dv by dt. Okay, we can interchange this, or dl, it is same as this. Okay, dl by dt is nothing but again, or you can write down mv dv. Okay, dw. And we are interested in total work, not just differential work. That's why we'll integrate this, and from velocity 0 to w, from velocity v1 to v2, we'll get w is equal to take him outside. Okay, W is equal to m into half v2 in bracket v2 square minus v1 square. Okay, I will write down neatly. Just a second. Main thing here, kinetic energy is half m square and work is half m into difference of v2 square minus v1 square. Okay, why is this? What is the difference between energy and work? Okay, we will see in next video because time is running out. Thank you.